Okay, the goal of this video is to create an equivalent circuit model for a specific motor. We're going to be doing the 681A. So the first thing that we need to do is we need to draw the basic equivalent circuit. So the basic equivalent circuit has an applied voltage. It has an equivalent series resistance, an inductance, and a back EMF. And so then this is going to be KE times omega. This is going to be L. And then this is, so these are the parameters that we're trying to get. So let's go and grab our 681 motor. Okay, so here is our spec sheet from the motor. And the things that we're looking for, let's move this over. Is we're first of all, let's look for our resistance. So we scroll down here. And here is our terminal resistance. They have different windings, so we have the A, B, and C. We're grabbing the A, so this is what we want right here. So this is our RA right there. So we could put that in as the 0.3. Similarly, we want to grab the inductance. So here is our inductance right here. And again, we have the A, so it's 0.8 in millihenries. Okay. The terminal voltage is right here, so this is 90. And then we need our KE, and so then that's going to be our back EMF. So you see here is our KE, but you see it's in these units right here. We typically want it in units of volts per radians per second, but we can grab, this is 7 right here, so we're going to have to do some unit conversions. So let's look at our unit conversions. So we had, what was that number? 7. So we have 7 volts per kilo RPM. So the first thing that we're going to do is divide by 1,000 to get it into volts per, so we have 7 over 1,000 volts per RPM. Okay, and then we want to convert our RPM into radians per second. So we get so 1 RPM is 2 pi over 60 radians per second. So we plug all those numbers in, and we have 7 divided by 1,000 times 60 divided by 2 pi. So this has a KE equal to 0.0668. The last thing that we need is our KT, and we want that in units. So here is our KT. We have it both in ounce inches or Newton centimeters. We want to keep it in these units, but we want to convert it into Newton meters instead. So this is a 6.6. We want to divide it by 100 to get it into Newton meters. So this is going to be 0.066 Newton meters per amp. And so you can kind of see that these two are really close if you have them in the right units. And there we have it. There is our final circuit, equivalent circuit design.